All right, we're applying this theorem 1. Remember, functions increasing when derivative is positive, functions decreasing when derivative is negative, okay, right? We talked about that on page 120. Now, in this example, what they give us is the graph of a derivative function, okay? And they're asking us to find where is the original function increasing or decreasing. Look at what I do with my highlighter over here, okay? I'm going to highlight the section that is above the x-axis in red, okay? Above the x-axis means positive, right? So f prime is positive to the right of what number? 3, okay? So from 3 and on, 3, 4, 5, 6, all the way to forever to the right, the derivative function is positive. So what I get to say is this function is increasing on 3 and on and on and on. Well, why? Because the derivative is positive. I know this piece of the graph that's above the x-axis is positive, and this is the graph of f prime. So when it is above the x-axis, we know the original function must be increasing. Now look, I'm going to grab a different color highlighter and color this part. That is below the x-axis, right? You know what? I should write this down. Like this was above the x-axis. Therefore, f prime is positive. Now the blue part, that's below the x-axis, below the x-axis, tells me that f prime is negative in this region. Okay, so that is to the left of 3. So everything to the left of -3 and interval notation, that will be negative infinity to positive 3. So what happens at that point 3? Okay, the derivative is 0. I may mark that. F prime of x is 0. Well, hold on. I think I want to change it to f prime of 3 is equal to 0. So the derivative is equal to 0 at 3. It's not above, it's not below, it's on the x-axis. So what does that mean? Is the function increasing or decreasing? Well, it is stopped at that moment, okay? All right, they said sketch a possible graph of f. So I'm going to use this to sketch a possible graph of f, okay? So hold on, a number line. And I'll just put my very special point of 3, okay? Because 3 is where things would change, right? To the right of 3, the graph is increasing. To the left of 3, the graph is decreasing. So I may graph a picture that looks like this, okay? First, decreasing to the left of 3. So I may have a graph that looks like this. It comes down. But when it hits the 3, okay, what happened? It's going to go up to the right. So this is a picture that is increasing to the right of 3, but it was decreasing from the negative infinity to positive 3. So there is a graph, and all I know is, this is what it may look like, but I wouldn't know like all the details of it, right? So here's just a random graph, okay? Let's see. They want us to find the relative minimum or maximum value. Well, look at that U shape. This is the critical value right there, right? This is the lowest point of my graph. So I will call this relative minimum, not a maximum. This is the lowest value. And that happens at 3, okay? So this was an example on page 121. And, the trick is to really look above the x-axis for the interval where f is increasing and look below the x-axis for the interval where f is decreasing.